Aloha class, here we go, section 3.2 differentiability, where it's topic 2.4 of the AP exam course catalog, which is connecting differentiability and continuity, determining when derivatives do and do not exist. If we look at our learning objective, our essential knowledge is explain the relationship between differentiability and continuity. Here we go. All right, here we go, differentiability. Okay, to look at differentiability, what we like to examine is maybe when derivatives do not exist, okay? So enable us to do that here and get started. What we are going to do is we're going to look at a couple of graphs that you guys are very familiar with. The first one being an absolute value graph. That absolute value graph, hopefully we know, has a vertex at 3, 0, and on the right side goes up 1 over 1, up 1 over 1, and we get this beautiful looking V in both directions. Okay, and now let's answer a couple of questions about that graph. Okay, A, f prime of x as x approaches 3 from the left. So remember that prime guy means what's the slope of the tangent lines. Now if we look here at the slope of those tangent lines to the left of 3, the slope of each one of those guys is -1. If we look at f prime of x as we approach 3 from the right hand side, our slope would be +1. If you'll notice, these guys are a little bit different. If we look at continuity at x equals 3, do I have to pick up my pencil, class? No, I do not. And being that I don't have to pick up my pencil, yes, it is indeed continuous, where the limit from the left-hand side goes to 0, the limit from the right-hand side goes to 0, and the function value is 0. But let's check out D. Is it differentiable at x equals 3? Guess what? No way. A Jose. And the reason why, and we should always do a good job of explaining ourselves, is because f prime as x approaches 3 from the left-hand side does not equal f prime as x approaches 3 from the right-hand side. So, food for thought. When the left and the right side derivatives aren't the same, we say f of x is not differentiable. So this particular graph, it's not differentiable at x equals 3. Remember to hit pause if I went a little bit too fast or you need a little bit more time to write some things down. All right, here we go. Let's move this up a little bit and look at another graph. Do we remember what x to the 2/3 looks like? If you don't, it's kind of cool. We're kind of here at 0, 0. Okay, believe it or not, 1, 1, -1, 1, and then it kind of looks like a square root function, right? Kind of like our radical functions. Okay, and what we're going to inspect when we look at this guy is describe the derivative of f of x as x approaches 0 from the left and the right hand sides. So here we go. As x approaches 0 from the left hand side, f prime of x. Let's take a look at the slopes because they're kind of different, right? If I were to draw tangent lines, oh my gosh, they get steeper and steeper in the negative case. So f prime of x would go to -infinity. And then now let's look as x approaches 0 from the right-hand side. What's happening to my slopes, right? And if I drew all my slopes right here, they're all positive, but they look like they're getting steeper and steeper. So we would say that's +infinity. And do you know what's super duper interesting is we're going to learn later how to find the derivative of that algebraically, but it is actually this right here. And you know what's cool is let's go ahead and find out the value of that derivative at 0. So it'd be 2 over 3 to the cube root of 0, which, oh snap, that would be 2 over 0. And what's 2 over 0, class? That is undefined. How about that handwriting? It's getting a little bit better. Therefore, we say f prime of x is DNE, does not exist at x equals 0. Why? Because it grows without bound. Okay, and what's interesting when you really inspect it, it goes without bound. One going to -infinity, the other one going to +infinity. Remember to hit that pause button if you need it. All right, let's go ahead and move up even a little bit more now. If I'm going fast, you guys, please, please, please take the time to hit a little pause button, okay? Now, if I wanted to graph this guy, ooh, the cube root, what's that guy look like? A lot of people struggle. We always put values, right? 0, 0, 1, 1, -1, -1. And what's another good value to pick? Oh, 8, 8, 2, right? So that'd be up there a little bit, right? It kind of take that shape right there where it would go. It would narrow out. Sorry about that. And then it comes down here and it narrows out. And you know what? Something really interesting happens right about there, and that's what we're going to inspect right now. Okay, and we're going to do the same thing we did on that last problem. We're going to look as we approach 0 from both directions, okay? But as x approaches 0 from the right and left-hand side, guess what? F prime of x is undefined. Do you know why? You know what's cool is if you get out your calculator and you zoom in like crazy here. I didn't do the best job of drawing that graph. Okay, it's a little bit steeper like that. You kind of have what we call a vertical tangent line. And what do we know about vertical tangent lines? And we'll say it's undefined because it's a vertical tangent line. And a vertical tangent line has a slope of what? It has a vertical tangent line. It has a slope of 0. And so if it has a slope of 0, that is why it's undefined at that particular value. That's called a vertical tangent line. Remember that bad boy. Now, once again, what's super cool is later on we find out how to find the derivative of that, which is equal to that boy right there. Guess what's going to happen, class? When we plug a 0 in and we check this bad boy out, we get 1 over 0. Booyah! Exactly why it is undefined. And we could have known that just by looking at the graph. So, in a conclusion, a function is differentiable when it is continuous and has smooth transition of its slope. So, derivatives are DNE at, I'm going to try to write real nice here, at points of discontinuity. Okay, so that's 1. Okay, 2, at quote unquote, pointy places. What's a pointy place? Well, it could be a corner like we had earlier, and I failed to mention, shame on me, that little bird-looking dude is a cusp. Okay, corners when you have those slopes that are constants. Cusps are created when you have those slopes that are approaching infinity or negative infinity. And last but not least, at vertical tangent lines. Okay, and those are all the possible ways that our derivative does not exist. Okay, now here's one of the most important sayings we're going to say all year in terms of relating differentiability with continuity. And is differentiability, we got this really cool symbol, you guys. It's kind of like an equal sign with an arrow. That means implies. Okay, differentiability implies continuity. If f is differentiable at x equals c, then we say f is continuous at x equals c. Okay, let's go old school back to little geometry days, right? We had what we call a converse. If we have an original statement, if A then B, then we say the converse is B, if B then A. Let's see if it works for our theorem up here. Okay, so we're going to say if f is continuous at x equals c, then f is differentiable at x equals c. No, it's not. That is false. Okay, make sure you have that understanding down. Differentiability may imply continuity, but continuity does not imply differentiability. Now, back in your geo days, you learned something called a contrapositive. Okay, and the contrapositive is if we write if A then B, the contrapositive is if not B, then not A. So let's write one for that one, you guys. You know, it'd be awesome if you pause right now and see if you could do it all by yourself. If F is not continuous at x equals c, then f is not differentiable at, once again, not x equals c. And guess what? That is 100% true. Okay, and you know what, where these problems come up a lot on the AP test is sometimes in the form of a multiple choice. So make sure you understand the big difference. Number one thing in this page, and oh my gosh, is there a lot of red. Differentiability implies continuity, but continuity does not imply differentiability. Okay, so here we go. I almost thought I just lost that whole page. Oh no, you don't know the behind the scenes, but here we go. Example 6. If you are given that f is differentiable at x equals 2, then explain why each statement below is true. So this is given to us. Okay, like for example, right now, guess what just happened? The pen doesn't work. So I apologize, bear with me. Let me know if you can handle me using this guy again, okay? Okay, so I apologize, class, but this is unfortunately how it needs to be done right now is with this bad boy. Okay, if you are given that f is, and I know I'm repeating myself, but over here I'm starting over again. If you are given that f is differentiable at x equal to, explain why each of the following is true. All right, boom. The limit as x approaches 2 of f of x exists. Now guess what? Since we know that f is differentiable, what does that mean? That means differentiability implies continuity. Okay, so that's kind of what the narrative is as we go through all these problems. And so since it's differentiable at 2, we know it's continuous at 2, right? And if it's continuous at 2, we know that the limit as x approaches 2 of f of x is equal to f of 2. So we get answers for those guys, therefore it exists, so we're good to go. B, this bad boy is the original definition of the derivative. And guess what? If we have a derivative, if it's differentiable at x equals 2, that boy is good. So it's just really understanding that we can get answers for all of these guys, all right? That is equal to f prime of 2. F of 2 exists. I kind of answered that in A, right, when I did this little step right here. Since, and we need to make sure we write this whenever we have questions like this on tests or quizzes, if I ask for y. But since we know it's differentiable at x equals 2, we know it's continuous at x equals 2. Why? Because differentiability implies continuity, and therefore f of 2 exists. And then D, let's please remember that that is the alternate definition of the derivative, which equals f prime of 2. So we'll obviously get an answer. Why? Because they told us from the beginning that we would. Now to the very important multiple choice question that you see on the AP all the time. You get this bad boy there. And when you see that thing, what you want to do is you want to do a little bit of side work, even before you read these things, because you can get confused sometimes when you read those. And you want to write down, what does that mean? Is there any type of other type of notation I could use? And what that means, believe it or not, right there, is that is the alternate definition of the derivative. So that means f prime of negative 3, the derivative, is equal to 2. So that tells me a lot of information. For one, it means it has a derivative at x equals negative 3. And what's up? If it's got a derivative, what's that mean? If it's differentiable, that means it also has to be continuous at negative 3. So there's a lot of things you could put even before you start doing a problem. And sometimes that's the smartest thing you can do whenever you deal with these problems that are multiple choice or true-false questions. Okay, now let's look and see if we can see which one of these must, right? The important word right there being must be true. The limit of f of x as x approaches negative 3 does not exist. Yes, it does. Now, why does it? Well, that means it's a derivative. That means it's differentiable. That means it has to be continuous. Booyah! If it's continuous, I'm going to get an answer. It will exist. Get rid of that bad boy. B, f is not defined at x equals 3. Liar, liar, pants on fire. For sure, it's defined at x equals 3. Why? That means derivative. It equaled 2. That means I get an answer. That means it's differentiable. That means it's continuous. Definition of continuity is the limit as x approaches negative 3 of f of x is equal to f of negative 3. That f of negative 3 means we'll get a value. Once again, so sorry about that craziness. Booyah, get rid of you. F is continuous at x equals 2. Probably, but they're only giving me information at negative 3. So I don't know if that must be true. And then f of negative 2 equals 3. Once again, maybe it's f prime of negative 3 equals 2, which if I wrote that from the beginning, it would have helped me to figure that out. So guess what? That is correct. And I wrote it right there. Okay, so these can really cause a lot of trouble. I highly encourage you to do a little side work and investigate the problem even before you do it. All right, this next page here, you guys, is some calculator stuff, and we actually have a lot of different formulas. There's actually a third derivative formula, which is this. This is actually the program our TI-84s use to help us to find a derivative, but we don't need to be so concerned with that stuff, so we're going to go right through it. But what I do want you to do here to close out 3.2 differentiability is I want you to be able to use your calculator. So I'm going to try my best right now. If I'm not able to, see if you guys can do this stuff. Oh my gosh, check that out. It is highlighted. Is that coming up on your screen? It is highlighted and I'm circling. That's pretty cool. But I'm going to try to pull up my calculator right now, show you a couple ways that you can find the derivative using your calculator, okay? Okay, so let's bust out our TI-83s, and it's x squared minus 3x plus 2. Okay, so type that bad boy in your calculator. X squared minus 3x plus 2. Okay, and then what I want you guys to do, check this stuff out. It's pretty darn cool. If you do not have the most updated version, you guys, please make sure you come in and see me for help. Okay, I'm going to see if I can tap my screen here. Let's go, we're going to go to math. So this is one way you can do it, okay? We're going to use 8 because 8 is that n derived. That's the derivative, okay? And then, oh snap, shame on me, second quit. Let's get out of this screen first. Then we're going to hit math. We're going to hit 8. Okay, and we're going to find the derivative with respect to x. And what are we going to take the derivative of? This is kind of how we get that dy dx. Let's see, it's alpha trace. Now, hopefully you have this button because it gives you your options of what you could choose right there. So we're going to find, oh snap, dy dx. What are you talking about? Oh, I didn't finish it. So it's dy dx of, we're going to put alpha trace y1 in there, and we're going to do this at x equals negative 3. Ooh, I just put in a 3. Let me fix that. I don't know if I can get the negative button there or not because the screen's kind of in the way. So we'll do it for 3. No big deal. Okay, and I get the derivative is 3. Okay, that means the tangent line at x equals 3 is 3. Now what you're going to think is super cool, or at least I do, is there's another way to find the derivative in your calculator, and we're going to hit this zoom button and we're going to graph this bad boy. Okay, and there's my graph. And then what I'm going to hit is I'm going to hit second. So this is just another way you can do it. Second trace, okay? And then I'm going to choose dy dx. How about it? That must mean derivative. And then I'm going to type in just a 3. And what it says is it's going to give me the derivative at x equals 3. And check this out. It's pretty cool. It says the dy dx is 3 when x is 3 and y is 2. So it not only gives you the point on that graph, but it also gives you the slope. So if I said find the actual tangent line equation for that particular tangent line at x equals 3, your whole entire answer is right there. And you know what? We can change it up. Seems kind of weird that the answers are both 3 for that. And I'll prove to you that it's not. Let's go ahead and do it at x equals 2. It should be less of a slope, right? Because it's not as steep. So let's hit second, trace. Let's hit 6. And then I'm just going to type in a 2. It's going to tell me 2 comma, what was that? 2 comma 0, and I have a slope of 1, up 1 over 1. Check it out. Make sure you guys are doing your worksheets. I think this video is like only 18:12 because I went kind of fast. Let me know how bad it is when I use this pen, or it's doable. Because if I can't get this thing figured out, I might have to go back to the old videos, okay? You guys let me know what works best. Good luck on any tests or quizzes you got coming up. Maybe a pop quiz. Maybe not.